Yeah.
Okay. Anybody who wants to fight Steve on that one? Who wants to argue one way or the other? Yeah?
Yeah, of course.
Well, why did you think these ones aren't? What was your reasoning?
Because
Really? Why do you think these ones aren't?
okay, that I agree with that one.
You agree with which one?
One.
You agree with yours now. Why? Because Tarek poked you in the back? Tarek, why should he agree with his decision? Come on, you must have a reason.
I don't agree with his decision.
Oh, what do you
I'm just
think
saying
then?
that he needs to stick to his decision.
Oh, so you're saying stand up for yourself. Tarek, which one do you think then? What do you agree with?
Well,
This is why you're my
I'm not really sure.
You're not really sure.
I'm pretty sure all of them are equations except for 12x
Yeah, that's what I was going for.
plus 4.
This one? You
Yes.
think is or isn't?
Isn't.
You think it's not.
Yeah.
Okay, I'm going to pull you all in for a minute. I want you to listen really carefully to what I said. Ready? We're going to read the top line of this screen. It says, an equation is a statement. It should say where, not that. So an equation is a statement where two expressions are equal. Now think. It's a statement where two expressions are equal. Anybody want to jump ship? Stay ship? Where do you want to go?
Two up there
Up here?
are
So now you're going to what he said. You're saying these are equations and these aren't. But you just told me you wanted to jump ship.
no, I meant those two are equations.
So you're sticking with your original. Can either one of you back it up? Why?
Because if you say that x is 3, that's
Over here?
3 plus, sorry, not 3, it has to be 8. 8 plus 4 equals 12. 12 equals 8 plus 4.
Okay. Yeah?
And then the one on the bottom would be 3.
So right now you guys are too worried about trying to figure out the answers. Forget what the answers are. Tell me why they're equations.
Because they both equal the same. Two expressions are equal.
That whole literacy thing, did you guys just come from Mr. T?
Oh yeah.
Yeah! Look at that, the first sentence. This is English in math.
That's what I just said.
Two expressions are equal. I have an expression with what in between? An equal sign. I have an expression and an expression with what in between? I don't have an equal sign here. I just have an expression and an expression. Tell me why these are equations, Steve?
Because they have equal signs.
And that's as easy as you get to keep it. You just get to say because they have equal signs. Kira, why?
Because it has equal signs.
Because it has equal signs. Why? Because it has equal signs. So what makes an equation an equation? It has equal signs. Okay, make sense? All right, so this is what we want to talk about. Oh, we're going to skip this because this took way too long. Anybody know what solve means? Yes, Robin?
Basically, to find the answer.
Find the answer? Different answers? Or would you all agree with Robbie? Agree? Good. Let's agree with that and move on because we're never going to get through this lesson. If I asked you to tell me the opposite of addition, this is important, we need to know it to solve equations. What is the opposite of addition, do you think? Tarek?
Subtraction.
Oh, wow. Oh, he's right. What's the opposite of subtraction? Addition. And what's the opposite of multiplication? Division. Steve, what's the opposite of division?
Multiplication.
Multiplication. That's important. We need to know that. Because I need you to remember this. Ready? Solving equations means opposite operations. It means we want to isolate the variable. When I say isolate the variable, what do I want to do? If I want to isolate something, what do I want to do? Isolate. What does the word isolate mean? I want to isolate, who is this under me? What's your name? I want to isolate Jesse. I'm going to start isolating. I'm going to quarantine. You're going where? Quarantine. So what does isolate mean?
Separate.
Separate and get him all by himself. Okay? You go back to your seat, Jesse. So we want to isolate that variable, get it all by itself, and we do that with opposite operations. So that's why we needed to know that. Okay? So, really quickly. So the whole purpose of this is that we want to know the difference between locally developed math, applied math, and academic, right? So if you're in a locally developed grade 9 math or an academic, or sorry, an applied level math, locally developed, you're gonna have to know how to do this. Applied, you're gonna have to be pretty comfortable doing this. And academic, we're gonna take it to the next level. And have to be able to deal with fractions and messy numbers, where they're not always really pretty, okay? If I asked you to solve this, how would you do it? Hands up, don't yell at it. How would you solve that first one? Remember, what does solve mean? Jesse, what solve mean? Kira, what solve mean? Find the answer. How are we gonna find that answer? Find the answer of what? What am I looking to find out? The answer of an equation. Okay, so what is the answer of an equation? What do I want to find out?
A prime number that equals
It equals what?
A equals 3.
What am I, yes?
Find what x equals.
Find what x equals. Which means I have to get x all by itself. So how would I get x all by itself right there? Yes?
You can take 3 and subtract 6.
Okay, so, but listen to me, if I only subtract 6 here, then I have x plus 6 equals 3 minus 6. So x plus 6 equals negative 3. Is that what you meant?
No, but like you can take the final answer and subtract what you were adding to x to get what the value of x is, and then once you have x, you could add 6. And then
But then what happens to this 6? You can't just stop writing it. Steve, listen to my questions. So see, when we're in an academic math class, we're going to listen all the time when the teacher speaks. How do I get rid of the 6 on this side, yeah?
You might be able to do the equation backwards.
Okay, yes? Which is kind of what you were doing, right? Is that kind of what you were doing? Sorry, I don't know your name, honey. Katie, is that what you were doing?
I guess.
I guess what I'm asking you, okay, let's go back to my original question. Remember I said we had to isolate that variable? We had to get it all by itself? So forget that there's a 3 on this side right now. How am I going to isolate that x? How am I going to get it all by itself? Forget about the equals 3. How do I get x to stand all by itself, Tara? Oh, I thought you had your hand out. Well, think about this. Say it's me and 6 of you. I want me to be all by myself. Sometimes I need some air.
You tell them
I tell them what? So I get rid of the 6 kids. I send them to see Mrs. Grell. They get, go bug Mrs. Grell.
Still, they're not there. She's right there.
I know, but if she wasn't here, I know, you're right. But let's pretend she's in her office. So I send you 6 out here to go visit her. So I did what to you? I got rid of you. I did get rid of you. What do I need to get rid of here? How do I get rid of plus 6?
negative.
I'm minus 6. Just like I'm minus 6 of you out of my classroom. Do you get that? Because what happens if I have 6 and I'm minus 6? What do I have?
0.
I have 0. So let's try to do that. So I'm going to minus 6. So now, you agree I just have x on that side now?
Yep.
Okay. So here's the thing with equations. Equations have an equal sign in them, right? What does it mean when something's equal? What does the word equal really mean? See? It's, oh my gosh, you picked a perfect word. You couldn't have picked a more perfect word. Did Miss Matthew whisper that?
Yeah.
Oh, Miss Matthew. Steve, I was giving you credit. You could have said no. She would have been happy if you said no. So I'm balancing it. So listen, if equal means balanced, and I kick 6 of you out, well, what just happened to my balance?
It's gone.
It's gone. So what do I need to do?
Add 1.
Add what?
You're only one person.
Add
6.
Okay, so, but did I add 6 to this side?
No, you don't get in there.
So what do I want to do on the other side? So, right, so how do I get this to come down where this is? How do I make it even? What am I going to do? I took away 6 on this side. What am I going to do? Take away 6 on the other side, and now I'm balanced again. Right? So so just like fractions, we all love fractions, right? We all love fractions?
No.
When we add fractions, what do we have to do? When we add fractions, we have to make a? Well, the fractions are division, but what do we have to make when we add fractions?
You have to make the denominator equal.
You have to make the denominator equal. So you change it, right? When you change the denominator, what do you have to do to the numerator? you have to change it too, right? Whatever you do to one, you have to do the other. An equation's exactly the same. Whatever I do to one, to isolate this variable, I have to do the other, right? So if I minus 6 here, what am I going to do over here, do you think? Minus 6. See, Steve, you do know. So now I have 3 minus 6. What's 3 minus 6?
It's still the same.
Sometimes in high school we throw our pens too.
Oh, you do?
So it's 3 minus 6, so it's negative 3. Does that make sense? So we wanted to isolate x. How do I get rid of addition? I subtract. If I subtract on this side, then I have to subtract on the other. We kept the equation balanced. Uh-oh. So this is locally developed. Applied would have to do this too. What are we going to do over here? This is still the applied level. Yeah?
So it's 2 and x, so you have to times it, so it's 2 times 9 times 4.
So you just figured out the answer. You did it all in your head. I want you to. So this is one of the things in high school. You got to take me through this. Okay, so I said this to the other class too. Let's pretend you did this question on the test, and you just wrote negative 3. I don't know that you didn't copy that off the person sitting beside you, but I want to give you the benefit of the doubt. So I'm going to give you 1 out of the 3 marks this question's worth. You're going to get 33%. You show me all this work, but still get this wrong. But I know you know what to do. You subtracted 6 from both sides. You just made a silly math error. You did what Steve did and forgot to put the negative sign in there. You're going to now get 2 out of 3. You at least got 66% because you showed me all this work. If you just do it all up in here and write down whatever you just told me that number was, 9, you just got 1 out of 4. You're now down to 25% because this question will be worth 4. Does that make sense to you? I need to know. You have to show me what you're thinking. Because in high school, you can fail. So if you keep getting 25%, guess where you're going to be the next year? Back in the same classroom. And you don't even get to necessarily switch your teachers because we're such a small school, there's not a lot of math teachers. So if you didn't like me one year, you're still going to not like me, but you're going to be in my class. Again, to do the same stuff. So just do it right the first time. Make sense? But this is something new, right? So this is what I wanted to be able to show you guys today. So how do we get to his? He's right, because the answer is 9. So let's think about what we did over here. Jarek, what do you think you might do?
So since it says minus 4 and it equals to 14, you obviously know that it's going to be 18 because it's, for the first two, it has to be 18 that'll equal up to because it's minus 4 to get to 14.
So how do I get rid of this 4 on this side?
Just,
How did we get rid of positive 6? We subtracted 6. How do I get a negative 4 to equal 0?
take away
A negative 4.
Oh,
I have to add 4. So remember we talked about all those opposite operations, right? So I'm going to add 4 here, which Tarek, if I add 4 over here, what do I get?
18.
18. That's what you wanted to get, right? Because you did the math in your head already. So now, negative 4 plus 4 is? So I'm just left with 2x, right? Oh, plus 18 over here. Now what do I have to do? Would I minus? What operation is happening here? What is 2x? What is that operation? Put your hand up when you think you know. Oh, I haven't seen your hand yet. It's multiplication. Would you guys agree?
Yeah.
Yes. What's the opposite of multiplication? What's the opposite of multiplication? Division. So guess what I'm going to do? So if I divide this side by, what should I divide by to get x by itself? 5? 2? 3? 5? 1? What do you think? What should I divide by to get x by itself?
18.
If I divide this by 18,
Yeah.
so what's 2 divided by 18?
9.
2 divided by 18? Remember, I'm trying to get x by itself. 2 divided by 18. 9. 2 divided by 18. So somebody said something over here. Who said that? What did you just say? Was it you? Who just said something about 18? Was it you? What did you say, Kate? 18 divided by 2 is what? 9. He knows he's trying to get to that 9. He knows he wants to divide this by 2. We're kind of going backwards here because you guys already know the answer. But if I want to divide this by 2 to get 9, what do I have to do over here? If I divided 2 here, I got to keep things balanced. Pardon, Kira? Divide 2 on the other side. Listen, the reason why I want to get 2, when you get x by yourself, okay, girls in the back, if you get x by yourself, is that the same thing as that? Is x the same thing as 1x? What's 1 times anything?
1. Oh, sorry, whatever the second thing is.
What's 1 times anything?
That thing.
It's that thing. So what's 1 times x? Are these two equal? Yes, they are. I'm trying to get this to be 1x. What do I have to divide 2 by to get 1?
2.
2.
Simple.
You guys need to all go home and practice your times tables. So if I, because knowing your times tables helps you with division, right? So if I divide both sides by 2, I get 9. Agreed? Okay. There's your locally developed and there's your applied. And anybody have a watch on?
It's 10 o'clock.
What time are we supposed to end this at? 10:10. Oh gosh. Okay. So now I'm getting into some academic math. We would maybe spend about 20 minutes one day and kind of go over this if you were in my academic class, but you'd kind of be expected to know it already. There's still stuff learning you're going to do with Mrs. Matthew, but you come into grade 9 expected to be able to do this. Then we're going to hit this. And it's starting to look a little bit messier, right? What do you, anybody want to take any guesses of what they might do here? X plus 3 divided by 2 equals 5. Just some guesses. Yeah? It's okay if you're wrong. Math class is a really safe environment, and you know what? We actually learn more if we make mistakes. So I actually kind of hope some of you make mistakes. I don't want to know what the answer is. See, so this was the trick today. I used really friendly numbers, so you could figure out the answers in your head. But I need to know you understand this, because eventually we're going to get to really hard ones where we can't do it in our head. They're going to have fractions and decimals and stuff. Stop, Jesse. Yeah, Tarek, what do you think?
Okay, so get rid of the x and the 3. So you have to divide by 2 to get to 5, and
Okay,
5 times 2 is 10.
Okay,
So-
stop right there. So you're telling me you want this to be 10 at some point.
Yes.
Okay.
You want
How do you make 5 10?
times it by 2.
I times it by 2. Tell me there's a reason why we're going to times 5 by 2 and then we want it to be 10.
Because you have to divide it by 2 later. Sorry, well, yeah.
What operation is happening here? What does this line mean?
Division.
So how do I get rid of this divide by 2?
Timing by 2.
Times it by 2. So remember, what I do on one side, I have to do on the other, right? So 2 divided by 2 is
2, 1.
1. So now on this side, I have 1 times x plus 3, right? And then I've got Tarek's 10. What's anything times 1 again?
Same.
Nothing. So I've got x plus 3 equals 10. Now what do I do? You're right, the answer's 7, but how do I get 7? The numbers aren't always going to be friendly. How do I get this? How do I get this all by itself?
Minus it.
Minus what?
3.
3. So if I minus 3 here, then I'm going to minus 3 here. Anybody, we're not going to do this one, but anybody have an idea how we might do this one differently? Because notice how here the 2 was underneath the whole x plus 3. Here the 3 is only under one term. So if we had to get rid of this 3, which is division, how are we going to get rid of it? By multiplying. What are we going to multiply by 3? Got it?
I'm guessing 2 and whatever x is.
So we are going to multiply this one by 3, you're right. We're going to multiply anything else by 3?
Yeah, the 10.
The 10? Anything else by 3? You shouldn't be kidding because you're right.
Oh, okay,
So what do you want to multiply by 3? The 4. Listen, because again, we have to keep it balanced. We can't just multiply some things. We have to multiply everything. Otherwise, we're going to start being lopsided again. Okay, but I'm going to run out of time. So I had this activity that Miss Matthew, maybe you can do with them tomorrow or something. But we were going to do what we call a parallel task. And in this parallel task, you were going to have a front side and a back side of the sheet. And I was going to ask you to do pick one to do. So if you're thinking locally developed or applied, I was gonna ask you to do this question. Derek and Sabrina are asked to solve an equation. Derek solved his this way, Sabrina solved hers this way. I wanna know who you think is right, and then I want you to explain why you think that person or both or either is correct. If you're thinking academic, now bear in mind, I was hoping we'd get to spend a bit more time on how to solve. So it's okay, again, it's okay to make mistakes. But give either one of these a try. We did just do one like this, and see if you can figure out who's right, Derek or Sabrina, and see if you can explain why. Remember that you have to be getting rid of our denominators. But this is more challenging, but that's one of the biggest differences between applied and academic, is that in that academic, you have to be willing to, number one, make mistakes. You have to be willing to take those risks, and you have to be willing to try those things. So if I asked you honestly, how many would look at these two equations and say, oh, I'm just going to do the easy one? Be honest. How many would say, I'm going to do the easy one? Only one? The rest of you would all accept, oh, look at that. Yeah, honesty's coming out, right? Most of us would. A lot, especially if it was for marks, right? But you have to, again, remember, you're going to get lots of marks for process, so you have to be willing to give it a try. So some of the things I want to make sure that you know, in both classes, all three classes, you'd be expected to participate in class. So all of you that have sat here and tuned me out, which I pretty much know who most of you are, you have to not do that, okay? The one advantage when you come to grade 9 is your class won't be this big, not likely. We generally get smaller class sizes because people choose different classes. So usually our academics range somewhere from 20 to 25, and our applied are like 15 to 21-ish, in around that area. So that's a real good advantage because there's less of you, so you have more one-on-one time with the teacher to ask questions. But you are going to be expected to participate, so you can't really hide behind other people. Okay? And if you take locally developed, there's usually 10 to 15-ish in that class. Okay? In the applieds and the locally developed, you may get asked to do homework. You're definitely going to get asked to study for tests, but you'll have a lot of in-class time. A little bit less teaching because you go at a slower pace, so we wouldn't teach as much in one day as we would in an academic, where we would teach more, therefore you'd be expected to do more work on your own at home. Which means you gotta have some pretty darn big reading skills. Okay? Which means if I have hockey and a job, so maybe I don't get all my homework done tonight, but I know tomorrow I don't have to go to work and I don't have practice, so I'm gonna catch up on both nights. You have to be able to have those skills to manage your time. Okay, that's really important. Sorry, the other thing that was on that last page was with the applied, you have to be interested in wanting to know certain things. But the biggest difference with the academic is that you've got to want to know the why. So the theory behind it, how you do things. Okay? Also with the academic and applied, the applied and the essentials are going to be more concrete. You're going to get to use a lot more math tools. We're looking for, in your academic, you want to probably get above a grade 70% in most of your math strands in order to have, like if you want to keep above a 70% in academic. It's not to say if you got a 60 in something you can't come to academic, but if you want to achieve high marks, which I hope everybody wants to, you've got to think about some of those things. And you want to have some really good learning skills. Again, time management, organization, how to put your notes into a binder, not losing everything so you have nothing to study from. Okay? And then I put a whole bunch of careers. The one thing I'm going to say that's different from you, or from math, than Mr. Devenish. Have you guys gone to see Mr. Devenish yet? Yes. So here's the biggest difference. With English, the moment you take an applied English or a college level English, you can't go to university. You're headed to college, which is awesome, by the way. But if you can take a college level math or an applied level math and still go to university. Because not everything in university is math-based. The only door you're shutting, if you really struggle with math, is you're shutting any kind of science door. So if you want to be a doctor or a vet or a vet tech or any of those jobs that are an engineer. Now, I'm saying that there are some engineer technician programs at college that you can go to with college level math. So all of these jobs are all college level or applied career pathways. Okay? Here are some academic ones. One of the biggest things and one of the hardest things for us to do is to make some of those choices. But at some point we all have to make those choices, right? We all want to be wish we could be doctors and be rich. I wish that I had a great big bank account. But at some point, I had to look at myself and say, I'm not gonna be a doctor. First of all, I hate blood, so that would be horrible. And second of all, I had to just say, you know what? I'm not smart enough to be a doctor, to be honest, and I don't wanna I don't wanna go to school for 10 years. So those are some hard choices that you have to think about, right? Because if you're gonna be a doctor, you're not just going to university for 4 years. There's more on top of it. When you go to college, it's gonna be more practical. My daughter went to college, she never once had to write an exam, because everything was based on placements and going out and doing hands-on work. So if you're that hands-on person, then those are great opportunities for you to do what you need to do. You feel like you know a little bit difference between the 3 levels?
Yeah.
Have I helped at all? Yes?
What's a toxicologist?
Toxicologist? You go look that up. Because you guys should start doing some research. So you look it up, and you come back and tell me tomorrow. Yes, Ms. Matthew, you can come tell me. All right, not tomorrow, I don't wanna see you tomorrow. Monday, you come tell me, okay? Okay, we got a date on Monday. So, listen, Ms. Matthew, I'm gonna give her the parallel tasks if you guys wanna try them at some point in time. And I'm also going to give Ms. Matthew, an exit card that we're gonna ask each of you to fill out. One side is literacy, the other side is all numeracy. So you gotta think back what you heard from Mr. D, what you heard from me. We've asked you a couple questions at the very end. We asked you to think about that presentation, what you saw today, and about what level maybe you think that you should take next year. Okay? Based on what you saw. Sound good? Anybody else have questions? Did you at least have some fun today?
Yeah.
Was it helpful, do you think? Was it such a
Yes,
good thing to do?
for
So
sure.
if we were planning next year for next year's grade 7s, or like this year's grade 7s, do you think we should do something like this again? Only
Yes.
maybe make them longer than 30 minutes so I don't have to talk so fast?
Yes.
Yes, I know.
She'll still talk just as fast.
Exactly. Okay, so, we good?
Yeah.